Right, this is a question that a student asked me over email regarding subnetting, and I don't quite understand the question that he was asking. So, well, obviously it was to do with subnetting, but the question was a bit confusing. So I've decided just to do a simple subnetting example on the board and store it in a video so that you can watch it later. So if this helps you, then that would be good. So what we're going to do, keep it nice and simple. Our first network here, we're going to have, well, first of all, before we start, this is the IP address that's been assigned to us, right? So it's 192.168.1.0 and it's a /24. Now the /24 tells us that the last, or the first 24 bits belong to the net portion. Oh, what's that about? Quickly undo that, quick. That's not in the script. Yeah. The first 24 bits, that's what the 24 means, is in the network portion. And the last 8 bits is the host portion. Now, we can't alter the network portion, as I've explained to you before, but we can manipulate the host portion and we can borrow bits from the host portion and assign them to the network portion. So what that does is it gives us more networks, but less hosts. And sometimes that's what we want. The reason why we do this is so that we can hierarchical networks, subnets, so as it makes it more secure and performance is better, and it's also easier to troubleshoot issues as well. So that's a wee bit of the background. So let's go on with this. We've been assigned this IP address and we're being asked to design 3 networks for this system, right? So the first network is to have 50 hosts. The second network also is to have 50 hosts. And the last network, 14 hosts. Now, the rule when you're subnetting like this is, if anybody says you want so many networks and so many hosts per network, you always start with the highest to the lowest. Okay, the highest to the lowest. So network 1, 50, network 2, 50, and then network 3, 14. Okay, so the first thing we need to do then, or the next thing we need to do rather, because we've done the first things, the next thing we need to do is work out how many bits is required in the host portion here for us to have enough address space for 50 PCs, right? So the solution to that is really, really simple. Okay, you just put a line. Just put a line down, right? It's not a 1, it's just a line, and say number 2, and then double it. Put another line down and double it. 4, and just keep doing that. 8, 16, 32, 64, and then stop. You stop when the number you reach is higher than the number that you need by at least 2. Now, let's say, for example, that was 50, and this is impossible, but if that stopped at 51, that wouldn't be enough. It has to be 2 higher than the number that you need, right? Okay, so how many times did we do that? 6 times. That means we need 6 bits, right? So we count from right to left. Why? Because we're working in the host portion, not the network portion, right? So it's 1, 2, 3, 4, 5, 6, and we put a wee line in there like this, a wee arrow on it. That's the host portion, and that's the net portion. Okay, so what we've done then is this is where the line originally was. Okay, that's the /24 portion there. So what we've done is we've moved that line down 2 bits and borrowed these 2 bits for networks, right? So as we can have more networks but less hosts per network. Now, first thing we want to do is work out our first network address. Now this is easy. It's always the same as the network address that was given to you, right? And how did we arrive at that? Well, as you know, these are just dashes in here at the moment, placeholders. So we'll fill these out with zeros. I'll not put, okay, there you go. These are zeros in there. Now, why are the zeros in there? Because it's a 0 there. Remember, this 0 is an 8-bit binary number. Therefore, each column of the binary number system is occupied by a 0. In other words, there's nothing in there. So we put the 8 nothings in there, the 8 zeros in there. See that? Okay. So then we just convert all of this back to decimal. Well, the first 3 bytes are already in decimal, so that's not difficult. So it's 192. The network address is 192.168.1.0, and it's identical, you see, but the only thing that changes is the slash value, the number of bits in the net portion. So we had 24 to start with, 192.168.1, that's 24 bits, and we borrow these 2, so that's 24 plus 2 is 26. So that makes that a /26 network. The other way to calculate that is you've got 32 bits in an IP address. You only need 6 bits for the host. So you have 32, subtract 6 gives you 26. Okay, so whichever way you do it suits you, that's the way it's done, right? So that's us worked out the network address. This is the first number that's within that range of available IP addresses, right? Get me my wee eraser tool and get rid of these zeros because we're going to change it all. We're going to change it all, right? Next. So next thing we want to calculate is the broadcast address. So if the network address is the very first, the broadcast address is the very last. If the very first one is all zeros, the very last one will have all ones, see? So we max out that portion like this, right? And then all we do is calculate the binary number in that byte. So the byte, remember, the byte, remember, starts, or rather, well, it starts, I've made a mistake here. Oh, that's a dot. Sorry, that's not a dash, that's a dot. So the binary number starts here, the byte starts here and ends over here. You don't just calculate it from the line, you have to include those two bits as well because they belong. Even though you've drawn that line in there, you still have the format of the IP address is still written the same with the four decimal bytes, okay? The 4 decimal numbers representing the bytes. So dotted decimal notation. So let's calculate that out. So 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 0 plus 0. What does that come to? I'll show you the quick way to do it. 1, 2, 4, 8, 16, 32, 64. Subtract 1, 63. Now, if you want to go and add all that up by yourself, a 1 plus a 2 plus a 4 plus an 8 plus a 16 plus a 32, you go ahead and do that. But I just know through experience that that comes to 63, right? And if you do it often enough, you'll realise that as well. So I'm just going to write that down. 1, 9, 2, 1, 6, 8.1.63, and it's still a /26, obviously. So that's our broadcast address. Now, so what that is the very end limit of the range of IP addresses. You've got the network address, which is the first one, and the broadcast address, which is the last one. And now you can't assign those to computers. Why? Because they're reserved for a special purpose. The network address is was the word I used there? Reserved. Is reserved for the network address, obviously, and the broadcast address is reserved so that the system, if something goes wrong and or whatever during the way it does systemy things, it can send a message to everybody simultaneously, and it uses that special address called the broadcast address. So we can't assign those. Now, you remember in the class the way that we tried to describe it in an analogy is you've got a book, you've got a shelf full of books, and you've got the first book and the last book, and they're all falling down. So what do? You put a bookend and a bookend, and it holds all the books in place. Now, if you want to read a book, you just pick it out and read it, right? So that's the range of books available for you to read. But you can't read the bookends. The bookend is only holding these books in place for you to access, right? That's kind of like the network address is like the first bookend, and the broadcast address is like the last bookend. Okay? So they're bookends. You can't read them, so you can't assign them. So that means then the first one, the network address, the first usable address is just the network address plus 1, right? So what's that? 192.168.1.0. So you add 1 to that. Well, that's not difficult, is it? It's 192.168.1/26, right? And then the last usable IP address, so you've used the first bookend and counted in 1 book, and the last usable, go right to the very end, get the last bookend and go back 1, so you subtract 1. So the broadcast address is 63, so the last usable IP address is 62 then, isn't it? So it's 192.168.1.62/26. Now that means our first network, right? We have an address space of 62 bits. 62 bits. We can assign 62 computers with unique IP addresses in this setup, okay? Is that right? I think so, aye. Yeah, of course that's right. 62, right? So, the first usable is 1. So the next usable would be 2, and the next usable would be 3, and the next usable would be 4, 5, 6, 7, 8, 9, all the way up till you get to 62. Then you stop, right? You can't go any higher than that. But I want to add another computer to my network. Well, you can't, right? Because once you do this subnet, and that's you, there's no going back unless you rip up the entire system and start from scratch, okay? So you have to be very careful in the real world if you're designing a network solution like this to make sure you have enough address space, enough bits for nodes, right? And then the last thing is the subnet mask. So subnet mask is 26 bits long. So let's just get rid of that wee squiggly giggly bit there. Right, so 26 bits long mean the first 8 bits is 192, right? So that's to tell me, the first 8 bits is telling me that 192 belongs to the net portion, so 8 bits is 255. Then the next 8 bits is telling me that 168 belongs in the address portion, so that's 255. No, it's not easy doing this. The number 1 there, although it's only a single number, it's still an 8-bit number, and that 8-bit number belongs again to the net portion, so that's another 255. So many bits is that? So that's 888, it's 24. So he says it's 26, so the next 2 bits belong to the net portion, right? So that means that the subnet mask from that dot to here would look like this, a 1 and a 1, right? And then 6 zeros. The 6 zeros, 1, 2, 3, 4, 5, 6, the 6 zeros here is telling me that the IP address above that is the host portion, but these 2 is the net portion. That means there's a dividing line. That's the net portion, that's the host portion here. Okay, so what's that binary number then in decimal? 128 plus 64 is 192, right off the top of my head. See that? Brilliant. Now let's just get rid of this. I hate a messy board. Let's get rid of this, right? So our first network is 192.168.1.0 for the network. Broadcast 192.168.1.63 for the broadcast. The first usable is the network plus 1, 192.168.1.1. And the last usable is 192.168.1.62, which is the broadcast minus 1. Okay? And then the subnet mask is 26 bits long, as designated by the /26 here. So if you wanted, you could just do 26 ones like that in a row, and then 6 zeros to make it in a 32-bit number. Then just draw a line in between every 8-bit like that, and then calculate them and convert them back to binary. Convert them back from binary to decimal, right? I'm not going to do that. We did that in the class a few times, so I'm not going to do it today. Right, next network. Let's be crazy here, right? Let's in our world have a different colour of pen for a different network. You can do whatever you like in your world, but in my world, I'm going to have that colour. Well, I don't know what that colour is. It's nice, isn't it? Look at that. Ooh, aye. Oh, aye. I've got a lipstick that colour. Right, so we've done all that. So we want to go to the next network, right? So it's a /50. It's not a /50. It's also 50 hosts. So we don't have to bother doing this again because I've already done it. So it's the same thing. So count in 6. 1, 2, 3, 4, 5, 6. Put your wee line in there like that. Net portion, node portion. So once again, we just zero all this out. Okay, just to keep ourselves right. Okay, so now if we were just to go ahead and apply the same process as we did here, it wouldn't work. Why? Because it's the same numbers. You just get the same numbers again. So that means you'd have 2 networks, and each networks would have the same network space. That wouldn't work. That's like it going into a city, right? And let's say you're going to Castlemilk Drive, and you've got 2 Castlemilk Drives right next to each other with all the same numbers. So where would you post a letter? 195 Castlemilk Drive, where would you post a letter? Which one of those Castlemilk Drives? It wouldn't work, wouldn't be a solution. So it's the exact same thing with a network, okay? So we need to change the network address portion. This is where it gets clever. This is where the magic happens, right? So there's 2 ways to do this, and I'll do both ways so that it allows me to double check. So what we do is we take the broadcast address here from the previous network, and we just add 1. Just like it, right? Now, if I take 63 plus 1 gives me 64. So then I have to then alter the bit patterns up here to reflect this. So what's that then? I need the eraser tool. Take that out very carefully there. Just take that out as well. It's in the way. Right? So that means I put a 1 in there. Now, why am I putting a 1 in there? Because that's the 64-bit column. The 64 column. So 1, 2s, 4s, 8, 16, 32, 64. So that value there, from this dot to the end, for this 8 bits, is the value 64. Okay? And that's our next new network address. So you just write that down. 192.168.1.64. See that? So the last one was 63. This one jumps up to 64. the last IP address in that whole range. It's just confused the issue. I shouldn't have said that. Never scratch that. Slash 26 because it's still a 50C. So nothing's changed there. So then we just go through the same process again, what we did before with the last numbers. I don't know why I'm pointing at the screen. It doesn't really work out that way, does it? Let's get the wee eraser tool. Take these, take these out. We can't take these out because that's the network portion. Can't change that, right? Get the pen back up, man. Right, so put all these zeros in here. And that's where we get that 64 from, right? That's why we get that. So then we want the broadcast address. So what do we do? Well, you know what you do. You just take out all those zeros. I don't know why I bother putting them in there. And then change it all to ones, because that's the maximum value, the maximum number that you can have, the very last number, right? And what do you do now? Well, you convert that byte, that lovely fuchsia pink, whatever it is, you convert that back to decimal, right? So 192.168.1.12. I've drawn the number. I mean, this is mental. My brain's wasted as sitting in the house all day. 127/26. How did I get this 127? 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 equals 127, right? Quick way to do it. Like I told you before, if you have a run of contiguous ones from right to left like this, all you do is go to the column where the 0 appears and subtract 1 from the value of that column, right? Watch this. 1, 2, 4, 8, 16, 32, 64, 128 minus 1, 127. If you want to add all those up, 64 plus 32 plus 16, 8421, you will still get 127. If that's the way you want to do it, go for it, right? However you arrive at the answer, I don't care as long as you get the right number. Okay? Now, that's the broadcast address. So the first usable is simply, get rid of all this again. The first usable is all zeros in here. It helps a bit if I do that. All zeros in here. And then we change this to a 1, so we increment that by 1. So that's all zeros, and then we add a 1, so that changes to a 1, obviously. Which means what? So you get the 64 there, plus that 1 gives you 65. The network address plus 1, 65. So it's 192.192.168. What did I say that was now? Too busy speaking it in German numbers and making a fool of myself. 65 slash 26, right, 26, like that, okay? Last usable. So to do the last usable, change this portion here, the host portion, change it all to ones. That's the broadcast address. And then the last one, take that off and make that into a 0. Because that's the very last number you can get that can be assigned. So it's add all this up. Well, I'm not going to bother adding it up. Do you know why? Because I've already done it. So all I have to do is get the broadcast and subtract 1. So if I added all that up, that would give me 126. See? That's 192.168.1.126/26. And the subnet mask is the same as over here. It's not changed. 255, 255, 255, 192. Kudos to David Marshall, by the way, for discovering this wee app. It's fantabulous. Alright, so that's us done 2 networks. Now we want to do a final network. Now things change a little bit here. The process is exactly the same. How we all do it is exactly the same. But we just need to change something because we only need 14 hosts. First thing we're going to do is change the colour of the pen. We're going crazy today. I mean, this is mental. 4 colours on the board at once. You can have as many colours in your world that you like. If you just have a world with 1 colour, that's fine. My world is having lots of colours. What colour shall we use? I'm going to go for choices. I'm going to go for that nice kind of sky blue colour. That reminds me of the summer a wee bit. Right. Now, 14 hosts. Same process as this thing here that we've already done. Just do that again. Now, it's not a number 1, it's just a line. Do a line and say 2. Do another line and double it to 4. do another line and double it to 8, do another line and double it to 2, 4, 8, 16. Double it. So how many bits did we, many lines did we draw? 4. How many hosts do we need? Sorry, how many bits do we need for 14 hosts? 4. 1, 2, 3, 4. Just like it. Right? Just like it. And so this is the net portion. This is the host portion. Now, look over here. We've already used that pattern, so we have to put that pattern back in because that was used in the network. If we don't change it and leave it, right? If we put it back to 0, we'll just repeat that pattern over there. And that messes things up. So we need to keep that as it is. And then we're going to do something magical in a minute, right? Put the colons in like that. Use like, and keep it all nice and tidy, right? I mean, the board, it's difficult writing on this. It just looks a bit like road pizza, doesn't it? It looks like a jigsaw that's failed. So, anyway, where were we? Right, so we want to work out our next network address. How do we do that? Told you how to do it. You take the last broadcast and you add 1. And what does that give us? 127 plus 1 equals 128. Right? Now, that's the same as doing this. Look, there's the network portion. If you just add 1 in there, 1 plus 1 is 0, carry 1. And that gives you this pattern over here. Oops. What did I just do there? Oh, aye. That gives you that pattern there, like that 1 and a 0. There, see? And then we just fill the rest out with zeros. Now you look at that binary number and tell me what that value is. 1, 0, 0, 0, 0, 0, 0, 0. The binary number is 128. Oh, look at that. Would you believe it? It's the same as 127 plus 1, 128. Let's write that down as our first network address. 192, I need to stay off the cacodamol. 168.1.128. 128, no, 1. We undo things. It'd be good if you had an undo button for your life, wouldn't it? So like you go into the, you get your wages, your £1,000 for the week, right? And you say, oh, what'll I buy? And I'll go into the bookies and you say, there's a horse. I like the name of that horse. And you put the £1,000 on it and you go, yeah, I should have dancer. I'm going to have a fortune. And it gets beat. And you've got to get him to the missus and say, I thought I was going to win. But if life had an undo button, and you'd be right back to where you were with your £1,000, you go, I'm not going to be that stupid, am I? I'll just put 500 on. And then you hit undo again. See? Anyway, so what are we? 192.168.1.128 slash, now it's changed, hasn't it? So it's a slash what? We've only used 4 bits now, 1, 2, 3, 4 line. So that's 32 bits in total. Minus 4 gives us 28, right? Or another way to do it, 8 bits there, plus those 8 bits there, plus those 8 bits there. 3 8s is 24, 25, 26, 27, 28. 28 bits in the net portion. 4 bits in the host portion. 192.168.1.128/28. Broadcast address. Oh, how did I do that again? Oh, I remember now. Get the eraser tool. Just like it. And wipe out the zeros. And then replace those zeros with 1s, the maximum number available. Right? Oops. Oh, what's happening here, man? It's not working because it's too near the B tool. There you go. That'll do it. Right? And then what do I do now? I just add up that value. So it's 1 plus 2 plus 4 plus 8 is 15. Here's another wee secret trick. 1, 2, 4, 8, 16 minus 1, 15. So that bit there's 15, but it's not 15 only. Remember this here. This is all part of the same byte. So we have to add the 1 to 8 in as well, 1 to 8 in as well. So I don't know the answer to that. I'm not very good I'm not very good at spelling. So 5 and 8, 13. 1 plus 1 is 2, and 2 is 4, and 1 is 143, right? So that's 143 is a maximum. That's a broadcast address. Oh, I needed a bigger eraser than that. Right, so 192. What was that number again? 14. Oh my goodness, is that not just ridiculous? 143 it was, wasn't it? I'm going to have to check that. 128. 128. I mean, how are you meant to learn it? Not for me. 128 plus 15. 5 and 8 is 13. 1, 4, 3. I'm going to leave that there. Leaving it. I'm not going to touch it. 192.168.1.143 slash 28. I can get rid of that now because I've done it right. Just get rid of this stuff, clean the board up a bit. Don't need any of that horrible foamy spray now, boys. First usable. Well, it's just the network +1, so 1. So I'll just show you that visually as well, so you can fully understand how that works. Right, so if I was to put all the zeros back in there, right, so that's going to give us 128, isn't it? But I want to change that there to a 1. So what does that give me? 128 plus the 1. 129. It's not difficult. 192.168.1. Hold on. That's not very good writing, is it? Let's do that again. 192.1. That's not much better, is it? 192.168.1.129/28. 28. Right, and then the last usable, well, that's just the same as having all these set to 1s in the host portion only, and then subtract 1 off of that would give you a 0 in there. So what's this 111? So remember that was 15, wasn't it? We were all 1s, take it was 14. So it's 14 plus that 128 gives you 142, or just subtract 1 off of that. See, 142. 192.168.1.142/28. And the subnet mask will now change. Now the subnet mask is 28 bits long, so the first 8 bits will give you 255. The next 8 bits is another 255, and the next 8 bits is 255. That's 24. And then we're going to have 25, 26, 27, 28, 29, 30, 31, 32. So the last part of the subnet mask looks like that. And if we were to convert that, that would give you, what? 240. How do I know that? Just not from doing it all the time, but here's a quick way. The maximum value you can get from this is 255, as you know, right? And this portion is switched off. So I've already worked out that 4 1s gives you what? 15. So if it's switched off, just subtract 15 from 255. There, gives you 240. Or, if that confuses you, just add up 128 plus 64 plus 32 plus 16, and that'll still come to 240, okay? And that's it. That's subnetting. It's that easy. And it's fun. And it's exciting. Okay? So, they might say, so network number 1 over here, this is going to be assigned to hosts, and we're going to assign that one to hosts, and this one might be left as a spare, for example. It means we can come back to that some other day. Now, you can have 3 networks, 4 networks, 10 networks, 100 networks if you want. You can do as many as you like, as long as you work with the highest number of hosts. Why'd you do that now? Oh, highest number of hosts first to the lowest number of hosts last, okay? Make sure your highest to lowest, and that's it. That's it. It's that simple. Adios.